Now we will talk about the two main transport layer protocols in the TCP IP protocol. The TCP Transmission Control Protocol and UDP User Datagram Protocol. The transport layer in the ISO-OSI model, of course, is layer 4, and in the TCP IP implementation it is implemented in two protocols, the TCP and the UDP. You either use this or use that. You use the TCP for reliable communication if needed, or you use the UDP for unreliable communication if this is the needed mode. The transport layer is responsible of session multiplexing. Multiplexing means that several inputs leads only to one output. This is the responsibility of the transport layer, to let every service at the source talk specifically to the corresponding service at the destination side. It's responsible of flow control if needed. It's responsible of adjusting the flow of the data according to the slowest side, either the sender or the receiver. It lets the faster side slows down to be suitable for the slower side. It's responsible for reliability if needed, for loss detection, for error recovery end to end. It's responsible for dividing data into segments, adding the port number, and the port number is a very important identifier to identify the type of service requested from the client to the server or from the source to the destination. It is responsible for the communication socket to socket. And let's see what is a socket. The socket is a combination, as we can see in the diagram, is a combination between the IP address that we have talked about and the port number that we need to talk about now. What is a port number? It's the identifier for the service. Each port number is associated with a certain service over the internet, especially the port numbers ranging from 0 to 1024. The length of this port number is 16 bits. That's why we can say that the port number can range from 0 to 65,535. Among these port numbers, the port numbers ranging from 0 to 124 are the well-known ports. For example, port number 80 is for the HTTP, port number 21 is for FTP, 53 for DNS, 25 for SMTP, Simple Mail Transfer Protocols. Port numbers larger than 1024 is called ephemeral ports. Ephemeral ports means that they are not the well-known ports, not associated to very well-known services, but can be used for the communication from the client side to the server side, while the well-known ports are dedicated on the server side for each of the services such as HTTP, FTP, DNS, or SMTP. Here is the socket communication. Here we can see the socket address, IP address, and port number forming a socket address. This socket address is at the source, and a corresponding one is formed at the destination from the IP address of the destination and the port number at the destination. Here is a socket at the source, another one at the destination. They are communicating with each other in socket-to-socket communication. This is the responsibility of the transport layer, layer 4, the responsibility of the TCP protocol or the UDP protocol. Let's compare between the reliable communication and the best effort communication. The reliable communication is connection oriented. No data transfer before connection establishment. But in the best effort communication, it is connectionless. Data can be transmitted without establishing a complete connection or a complete session, complete circuit from the source to the destination. The protocol used for reliable communication is the TCP. The protocol used for the best effort delivery is the UDP protocol. The reliable communication provides a means of sequencing, the sequence number in the TCP protocol. In the best effort delivery, you cannot specify the sequence of the data, which is before which or which is after which. The uses of the reliable protocol are for transferring email, file sharing, downloading files. The best effort delivery is for transferring voice or video. In general, it is for real-time data. It's for data that is delay sensitive and not loss sensitive, such as the voice streaming or the video streaming, where UDP is much more efficient than TCP. The UDP protocol as the first protocol in the transport layer. It is used in the best effort delivery. It is unreliable, but it provides application with access to the network layer. It saves the overhead of reliability mechanisms. It saves the acknowledgement, saves the sequencing of the data. Each of the acknowledgement and sequencing needs adding headers, and the UDP protocol saves this header and saves bandwidth for the data itself, the voice or the video being transmitted. It's connectionless protocol. No connection establishment before sending data. You send data and you are not sure that the recipient is there, the recipient is up and running, the recipient will receive the data in sequence. It has a very limited error checking, and this checking does not include recovery of errors if existing. It is not resilient to data loss, and data losses can be due to routing errors or duplication. The UDP protocol provides no data recovery features for such losses, so it is completely unreliable, and therefore it is used with the delay sensitive data and not for the loss sensitive data. The UDP header is simple and it does not provide any form of error recovery, so it is simply composed of the source port, the destination port, the UDP length, and the UDP checksum that checks on the header only. It does not provide error recovery, does not provide acknowledgement sequence number, as we will see later in the TCP protocol. The TCP protocol is the reliable protocol. It's the reliable version of the protocols that are acting on the transport layer. It provides access to the network layer for applications just like the UDP, but it is different in the way that it is connection oriented protocol. Before data transmission, there should be an establishment of connection, complete circuit between the source and the destination. It provides error checking. It provides data recovery features end to end. If there is data loss, data duplication, or any change in the data from the source to the destination, the TCP protocol can detect this, can detect the loss and the duplication in the data, and can recover this by resending the data itself. It provides sequencing of data through the sequence number header that existing in the header of the TCP. So if the arriving data is in a wrong order, the sequence number helps the receiver to reorder the data to the right order. It provides acknowledgement of receipt, so by this it can face the losses on the network and can detect that some data are lost and can be resent by the source. The TCP protocol, for the sake of such features, the features of data recovery, sequencing, and acknowledgement, is more commonly used than UDP because it is reliable, because it is more error resilient, so it is more commonly used than UDP, especially for web transfer, mail transfer, and file transfer. The TCP header is of course more complex than the UDP header. We can see the source port, the destination port. We can see the sequence number used for sequencing data. We can use the 32-bit acknowledgement number, which is used for acknowledging data being sent. We can see the 16-bit window size used for flow control. We can see the checksum, which is the checksum anywhere used for checking errors across the header and the data. We can see the 16-bit urgent pointer, which points on the urgent data inside the data field. If this field, for example, contains the number 2000, this means that the byte 2000 in the data field is urgent and needs to be processed before its turn comes. So this is the TCP header. We have some flags for the urgent field, for example, for the acknowledgement, for the push, for the SYN, for the FIN, that are used for the three-way handshaking used at the beginning of the session of TCP communication, and the four-way handshaking used at the end of the session of TCP communication. If we try to map layer 4 protocols to applications, layer 4 protocols and the port number to the application protocols, we can see that the FTP protocol uses port number 21 and uses the TCP as the transport layer communication protocol. Telnet uses 23 as port number. Telnet is used for remote administration. It is used by a client to administrate a server remotely and act as if sitting on it, copying and pasting and formatting the machine from another remote machine, and this is done through the port number 23. The HTTP, the Hypertext Transfer Protocol, uses port number 80 and it uses the TCP protocol. So it is reliable, so it can correct some errors, it is resilient to data losses. The DNS is a special case. It can use the TCP and can use the UDP. In both cases, it uses the port number 53. It can act in a reliable form using the TCP protocol. It can act as unreliable form using the UDP protocol if speed is more important than reliability. The TFTP, or the Trivial File Transfer Protocol, uses port number 69. It is just file transfer without any username or password or something like this. It is faster file transfer than the normal FTP. The SNMP, or the Simple Network Management Protocol, which is used for managing the network. It's used for communication between the routers. It is a protocol that is used to manage the network and make it faster and more robust. It uses the UDP protocol for the sake of the speed and the sake of being faster, and it works on the port number 161. By this, we come to the clear demonstration of both the TCP and the UDP protocols acting in the transport layer of the ISO-SI model and the transport layer of the TCP IP protocol as well. Thank you.
Subscribe now and press the bell icon. Never miss an update.